I'm about to take a test. I'm about to take a test. Why does this have to be so incredibly consequential? Why does my entire life depend on this test? Come on, man. Why can't it be more relaxing? It wouldn't be so stressful if there wasn't a time limit. The time limit is pretty long, but still. Oh, man. I just love how our Unit 2 review questions worksheet doesn't even cover anything from Chapter 7, which obviously means that it's not even a comprehensive review sheet. It doesn't even completely prepare you for the test. It only somewhat prepares you for the test. So then what the heck is the point of that? Okay, never mind. But I worked through this whole thing, so at least I'm prepared for this. Well, I didn't work through the whole thing, but I read through it. But I have everything I could possibly need to. And I have all these tabs open because I'm under the impression that this is open book, because there's nothing at all indicated anywhere that it is closed book. And if it doesn't say it's closed book, then I'm going to assume, because basically I had the same situation last semester with a class where it didn't actually say whether it was open book. So then I emailed the professor and she said it was open book. Well, then why didn't it say that? But anyways, so I could basically look in the textbook, I can look at previous quizzes, I can even look at the summarized versions of the textbook. And of course I can look at all my old homework assignments if I need to. And in fact, I could even look at the answer keys from the homework assignments I did. So I have so many different ways I could complete this test. But the problem is I only have 2 hours, so I don't know if I will be able to. That was fun. And I got an 88% on the last test, but I think it was mostly because... Oh, you know what? Oh, dude. I think there's going to be some short answer questions. Because I think the last test actually did have some short answer questions. Oh, no. Stop. Oh, no. But anyways. I'm definitely going to start the test. 9:45. It's due at 11:59. So if I was to start it right now, I would finish it by around 11:30 at the latest. And it's due by 11:59. Oh no. Oh no, I don't want to start. I don't want. Oh no. Oh no. Oh no. Oh no. Oh no. Man, I would be so less stressed out if there wasn't a time limit. I would be so relaxed. But I'm so stressed because of the time limit. Man. Obviously tests... Yeah. Because the time limit shows that how well you know the material, because if you know it very well, then you will finish it, then you will get a good grade even though it's only 2 hours. But if you don't know the material at all, you'll get a bad grade because you won't be able to find all the information in the 2 hour time period. Also, the time limit gives me the impression that it's open book, because if it was an open book, If it was closed book, then there wouldn't really be a need for a time limit. But oh no! Oh no! That was. Oh no! Oh no! Oh, it's taking time to load. That's time that you're decreasing. Okay. How many questions? Oh, really? Okay, fine. But 23? Oh no. Can be estimated from long-run relative frequencies of events are objective. Next. Let A and B be the events of the FDA approving or rejecting a new drug. They are mutually exclusive because you can either approve or reject. You can't have both. Measure variables with different means and standard deviation on a single scale. Different means. I believe that's what it is. I'm not going to go into it any more than that. Standard normal has mean of 0, standard deviation of 1. Mean of 0, standard deviation of 1. So far, this is exactly copying the review sheet. Oh my gosh. Measure the length of time between arrivals. So the length of time between arrivals is exponential. So yeah, this is copying the review sheet, like pretty much word for word. That's funny. Okay, which of the following are reasons for why simple random sampling is used infrequently? Okay, so this is not from the review sheet. That's hilarious. Samples can be spread over a large geographic region. Requires all sampling units to be identified. Great. I might want to look this one up. Simple random sampling. So I know where this is. This is a question from chapter 7. And it was not covered in the review sheet because of course it wasn't. But anyways, I believe I know where to find this answer anyways, so I'm fine. That is word for word from the textbook. Oh my gosh. That's funny. The sampling method in which a population is divided into blocks and then selected by choosing. So I believe that is actually cluster sampling, weirdly enough. That was not on the quiz. Because the quiz, okay, wait. I need to hurry up. I can't waste time. But I'm just gonna look up cluster sampling just to be sure. I don't want to get it wrong. That was funny. They don't really give a clusters. It's funny how they use the word cluster in the definition. So cluster sampling, that was funny. Theorem that states that the sampling distribution of the sample mean is approximately normal when the sample size n is reasonably large. I think it's central limit theorem, I believe. I don't want to waste any time. I'm just going to say that. The averaging effect means that as you average more and more observations, variance decreases. That was a quiz question I just read. They give the answer to another question right here. More than 30. That was another quiz question. Standard error is... So the approximate standard error is sample standard deviation divided by the square root of n. I literally just read that, I think. I just got a Discord message. Whoops, I guess I can't look at that. But that's going to bother me, so I'm going to close it. I need to focus on the test. I don't have time to read a message until after the test. But anyways, the approximate standard... Okay, I think it's this. Standard... Do I have... I wonder if I have that open. Wait, is standard error? No, it's in chapter 7. So we're just gonna double check that one because I might have misremembered the formula, but I think that's right. Where is it? Here. Approximate is S divided by square root of n. Yep, that's correct. Finite population correction factor, that is a typo, should generally be used when n is more than 5% of the population size. Let me just double check. So when it's more than 5%, because less, you don't need to use it. If it's more, you use it. So use it when it's more than 5%. There. We are already most of the way through this test. That's awesome. Well, in terms of the numbered questions. Non-truthful response is a particular problem when sensitive questions are asked, probably. Sampling error is equal to measurement error. No, it's not equal to the standard error of the mean. It's equal to the difference between the sample mean and the population mean. That's funny. The accuracy of the point estimate is measured by the accuracy of the point estimate. So that's kind of a weird thing. I think what they're talking about is sampling error. I'm going to go back to the beginning of the section. I'm going to just look at standard error because I don't think that's what it is. All right, so the accuracy of the point estimate is measured great. Sampling error. Next. All right, finally we got some 16 through 20 are the Excel problems. Are we going to put the answers in here or what? You know what's funny? Are we supposed to put our answers in this box? Okay, So it took us 10 minutes to do the multiple choice section, and now we have an hour and 50 minutes to do the Excel stuff. Okay. Number of reported on-the-job accidents. Number of accidents during a 1 month period. We have a discrete probability distribution for X. Use the Excel file. Unit 2 exam on-job accidents. You know what I'm going to do? I think I'm just going to close all the other ones. You know what's funny? They're probably in order in the downloads folder, so I should be fine to just close them and then use this. We have reported on-the-job accidents. Hopefully this is the right one. That was funny. 9 or more. Dude, what? Dude. I can't even read the note. What the heck? So on-job accidents. So calculate the mean, variance, and standard deviation. Find the probability of this, and probability of this. So this one's not too bad. Okay. So do we have to write our answers in the box? I feel like that's a waste of time to write the answers in the box, because I'm just going to write the answers in the Excel sheet. So find the mean standard deviation. Okay, squared deviations. Why is there a column for that? I don't think you need that. Mean. All right, so I hope this is right. Sum equals sum product. I hope this is right. We have this. Comma. This. That's all you do to find the mean. I'm pretty sure. So it turns out it's mostly 0, 1, 2, 3, 4, and it gets so low after that. It's like basically nothing. Sum product, and that should be the mean. 1.11. That makes logical sense because it's mostly up at 0 and 1. So yeah. Now the variance. So this is where I'm going to open that one thing, which is this one, because I need to remember how to do this. So to find the variance, you do sum product. So this is very weird. So what you do to find the variance is sum product. This part squared, so this part twice, the probabilities once, so this one twice, the probabilities once, and then you do minus the mean squared. So that was funny. So I will do that. So to find the variance, it's kind of complicated. Sum product. So this one twice, all of these twice, then this one once, minus this to the power of 2. I'm just going to double check. Here, I'll just push enter. We got variance. So we have sum products, this one twice, this comma this one once, minus this one to the power of 2. Double check one last time. This column twice, this one once, minus this one to the power of 2. So that has got to be correct. The standard deviation is the square root of the variance. Square root of the variance. That's all I need to know. And then the way they do this is awesome. Very fun. So, probability that, so given that it's more than 2, I'm just looking at a different thing. Probability that x is more than 2. Given that x is more than 2, so it's either this or this, of these two, of 0.4, what's the probability that's more than 3? So it's 0.1 divided by 0.4, which is 0.25. Yeah, I got the same result. So anyways, that means I can use my less complicated method. But anyways, the standard deviation is the square root of the variance. So I believe I do not need this anymore. So we got that, and we have standard deviation is equal to square root of this. So there you go. So we've done A. Find the probability that x is more than 2. So the probability that x is more than 2, I feel like I'm taking too long on this. How much time do I have left? Hour and 40 minutes. So the probability that x is more than 2 equals the sum. So probability that it's more than 2 means it's all of these probabilities. So there you go. More than 2. I'm just being super careful because it's a test. So there you go. Probability that it's x is more than 1 and less than 4. So the probability that it's more than 1 and less than 4. So more than 1 and less than 4. That's only 2 and 3. Because more than 1, less than 4. I got 0.15 again. How did that happen? 10, 12, 13, 14, 15. It's just a coincidence. Probability that x is more than or equal to 4. Dude, they didn't even have you do something given something. That's weird. Okay, well, thanks for making it easy. Probability that x is more than or equal to 4. Equals sum. So the probability that's more than or equal to 4, so equal to 4, and more than 4, so all these. So equal to 4 or more than 4. So more than or equal to 4, probability is 0.1. So there you go. There you go. I have completely finished 16. That was extremely easy. Man. Huh. It was a little complicated doing the variance and the mean calculations. I'm a little worried that she has square deviations here. I don't know why that's there. But I don't think I need that. Dude, imagine if I messed it up. Well, I'm not going to do anything else here. That'd be a little bit overkill. So, okay. So we have finished 1 out of 5 of these Excel problems. Good job. I'm not going to X out this. I'm just going to close it. Okay. So we have finished number 16. Next. Okay, if I have time at the end of the test, if there's some time left over, I'll copy all my answers into these boxes. But if I don't have time, I don't need to. So anyways. Oh my gosh, there's 6 parts to this question? Are you kidding me? Oh jeez. It's going to be the closest one to the bottom. Customer purchase amounts. Customer purchase amounts. So we have mean of 95, standard deviation of 18, approximately normal distribution. So these are going to be easy. All you have to use is use the normal distribution function on Excel to answer all the questions. Number 1, what is the probability that they spend more than $85? Probability, oh my gosh. Look at this. This, now I'm worried because the Excel sheet now differs from this. So now I'm worried that that happened on the previous one too. I'm going to go back. More than 2, between 1 and 4, more than equal 4. That sounds like what I did. Probability that they spend more than $85. So that's different. So this, I'm going to change it. I hate this so much, but this is the test. This is the test. Probability that they spend more than $85. What's the probability that they spend more than $85? So I'm going to change this to more than. Hopefully that's what they're looking for. Obviously that's what. So anyways, what we do is we actually do 1 minus norm.dist 85, mean of 95, standard deviation of 18, and true. So 1 minus that, it's 1 minus because we're looking for the probability of more than a number. But this function gives you probability of less than a number. So that should be correct. So, and just as an estimate, probability that we'll get more than 85, it should be a pretty high probability. 0.71. So that's definitely, that was funny. Stop. So probability that they spend between 85 and 105. So this one's interesting. That's fine. So first of all, we do the high number and then minus the low number. So basically, norm.dist. The high number is 105, mean of 95, standard deviation of 18, true, minus the low number. So 85, 95, 18, true. So it's a low number. It's a high number minus the low number. Please tell me I'm remembering that right. And it's going to be pretty high probability because it's like, yeah, I think, it's not even, please tell me this is right, please. C is, spends more than $45. Are you kidding me? Okay, spends more than $45. It's the same as 1 except with 45 instead of 85. Okay, so probably have to spend more than 45. So, so 1 minus hold on a second. Yes. Dang it. Equals 1 minus. So 45, 95, 18, true. Probability that it's more than 45, that should be a very high probability. 0.997. Part D. So they literally have part D, E, and F here in the Excel sheet, so you would think that she wants you to write the answers there. Like, why wouldn't you not? But anyways, okay, so part D is also part. Find the dollar amount such that 50% of all customers spend no more than this amount. Okay. 50% of all customers spend. It literally doesn't matter whether it's more or less because it's 50%. It's right in the middle, right? You just do 50% per 50th percentile. Even if it was saying spend more than this amount, it would be the same because it's literally in the middle. But anyways, 50th percentile is, we'll write here 50th percentile to make it easier for the grading, but equals a norm.inv, the probability of 0.5, the mean of 95, standard deviation of 18. So the 50th percentile should be close to the mean, right? It's literally just the median. 95. It's exactly 95. Oh man. So the dollar amount that such that 25% of all customers spend at least this amount. So, oh my gosh. I hate this. I have to figure out whether it's the 25th or the 75th percentile. So 25% spend at least this. So this or more. They spend this or more. Because if it was this or less, 25% spend this. I think this is actually 75th percentile. Wait a minute. Because 25% spend this or more means that they're in the top, not the bottom. So that means it's the 75th percentile because it's the top 25%. It's the top 25%, which means it's the 75th percentile. 75th percentile. So equals norm.inv probability of 0.75. Hold on a second. Oh, no, I'm so confused. Oh, come on. When you do percentiles, do you just put that number in? Okay, so logically speaking, this should be well above the mean. But if I get a number below the mean, then I'll know that I did it wrong. So the mean is 95%, or 95. Standard deviation is 18. Yeah, there we go. So that is correct. That is correct. You do put that. So there we go. And find the $2 amounts equidistant from the mean such that 25... Oh, you know what's funny? I think this is like a repeat of the question at the bottom of this test, or this practice thing. And not really. Equidistant from the mean such that 95% of customer purchases are between these values. So basically, the middle 95%, take 95 divided by 2. So equals 9 divided by 2, 47.5. And then equals 50 plus this equals 50 minus this. So we want this percentile and this percentile. Okay. Because we want 95 divided by 2, and then we want the middle 95%. That's the middle 95%. So we want this percentile and this percentile. So we want norm.inv probability of 97.5, comma 95, comma 18. Yeah. Oh, come on, how did that mess up? Oh, I get it. I was supposed to put 0.975. 0.975. There. That's better. That was funny. 0.025, 95, 18. So we got the middle two values there. We'll just put those in yellow. And those are the answers. So to find the $2 amounts that they will be between those values, that makes sense. So I think we're done with that one. That would be 2 out of 5 of the Excel questions, right? More than. Yeah, I don't know if they meant to do more than twice. But anyways, I'm just following what it says on here. I'm putting this above the Excel sheet for some reason. So, and I changed the Excel sheet to match it because this was different. It said less than, it said more than. But anyways, we're done with that one. So that was not too bad. That was funny. Close. So we only have 3 more Excel problems to get through. And you know what? I think I may as well just get it over with and just, because I don't want to risk anything, so that was funny.